Hello viewers, I am Kausalya. Today we are going to solve problems related with reciprocity theorem. The problem is verify the reciprocity theorem for the network shown in figure. So this is the given diagram, and in this diagram we are having a voltage source of 20 volt. So we need to calculate the current that flows at the extreme end, that is through this 2 ohm resistor. Right. So as usual, here we are going to calculate the total current, and finally we are going to find the current that flows through this 2 ohm resistance. Right. So as usual thing, we are going to combine the resistors, and finally we are going to make a single resistor out of all these resistors. So the first thing is, you see here, these 2 ohm resistors are in parallel. Right. So here you see the current at this node, it gets divided into 2. Therefore, whenever the current gets divided, then those two branches are said to be parallelly connected. Therefore, total resistance is given by 2 into 2 divided by 2 plus 2. So that gives a value as 1 ohm. So here these two resistors are replaced with a 1 ohm resistor like this. The rest of the things remains the same. You see 2, 2, 3, here 2, 2, 3, and these two resistors are replaced with a 1 ohm resistor here. Right. Now the thing is, when you look at this part, you see this 2 ohm and 1 ohm are in series because the current that flows through this 2 ohm also flows through this 1 ohm. Therefore, these two are in series. So 2 plus 1, that gives 3 ohms here. Again, when you redraw the circuit, here you see these two resistors are replaced by a single resistor 3 ohm. Now again, when you look at this circuit, it is obvious, right? These 3 ohm resistors are in parallel. So when you apply formula R1 into R2 divided by R1 plus R2, that gives the value of 1.5 ohms here. Therefore, here these two resistors are replaced by 1.5 ohm. Now again, these two resistors are in series, right? Then what about the total resistance? It is 3.5. So we know the value of voltage, we know the value of resistance. So now we are going to calculate the value of current. So it is nothing but 5.71 amps here. So this is the total current that flows through the circuit. So here we are having our 5.71. But what is our ultimate aim? Our aim is to calculate the current that flows through this 2 ohm resistor. Right. So we are proceeding gradually backwards. Right. So here it is 5.71 again. Where comes this 1.5? It comes from these two 3 ohm resistor, right? So again here flows the 5.71. Now this current gets divided between these two resistors. Yes? Can you imagine? Because this is the current that flows through this 1.5. This 1.5 comes from these two parallel 3 ohm resistors, right? So here this current gets divided between these two resistors. Since the value of the resistors are same, the current gets divided equally, right? Therefore, here I am using 5.71 divided by 2, that gives 2.855 amps, right? So instead of going by this way, you can even use the current division rule also. So what is the current division rule here? That is total current into opposite resistance. So here both the values are same. Actually, we need the current that flows through this 3 ohm. So the opposite resistance is 3 divided by total resistance is 3 plus 3. Right. Again, when you solve, you will finally end up with this answer only. Okay. Again, you will be having the same answer. Okay. It's up to you. You can use any method. So next thing is, when you gradually move upwards, you see this 3 ohm is nothing but it is a combination of 2 ohm and 1 ohm resistance. Right. Therefore, here what to say? The current that is 5.71 gets divided into two part. Okay. That is 2.855 and 2.855. So now this current, okay, this flows through this 1 ohm resistor. Where comes this 1 ohm resistor? This 1 ohm resistor is nothing but it is a parallel combination of two 2 ohm resistors, right? Now again you see here the value of resistors are same. Therefore, we can just simply divide this current value by 2, or else you can use the current division rule also. Everything is fine. So when you divide this 2.855 by 2, so here comes the answer as 1.427. So I am just writing it as 1.43 amps. So this is the value of current that flows through that 2 ohm resistor, you see. I'll explain from this diagram. Here flows 2.855. So when you again move back, that is in this part here I am having this 2.855. Right, because this 1 ohm comes from the parallel combination of these two 2 ohm resistor. So here it is 2.855. Right, so again this current gets divided between these 2 ohm resistors. So here I had simply divided this 2.855 by 2. That gives the answer as 1.43. So here flows 1.43 and here flows 1.43. Therefore, finally, the current that flows through this 2 ohm resistor is 1.43 amps. Right. Now, here the first part of our problem is over. Right. Here the method is very simple. Just you have to simplify the circuit in a normal way. Once after calculating the current, just you have to proceed backwards. Right. A little thinking is enough to solve this problem. Now, we are proceeding with our step 2. So what is our step 2? We have to change our current source, right? So this is our original circuit, right? This is our original circuit. Now I am going to redraw this circuit. So how to redraw? It is nothing but I am going to move this voltage source from this leg to the extreme end of the other leg. So you see here comes our 20 voltage source, right? So rest everything holds the same. Fine. Then as usual, here again we need to calculate the total current, and here we need to calculate the current that flows through the extreme end of this voltage source. Okay, here again we need to calculate the current that flows through this 2 ohm, that is the 2 ohm present in the left end, right? So again we have to simplify. So when you simplify, just we are moving this word, that is from left to right. Since we are having a voltage source here, we are simplifying the circuit from left to right. So when you look at this circuit, here these two resistors are connected in parallel, right? So when you simplify, we are getting the answer as 1.2 ohms here. Again, this 2 and this 1.2 are in series. Therefore, here we are getting 3.2 ohms. And again, these two resistors are connected in parallel. So when you simplify, what is the formula? R1 into R2 divided by R1 plus R2. So that gives the answer as 1.2307 ohms. Right. Again, when you look at this circuit, here these two resistors are in series. We know the value of voltage. So it is very easy to calculate the current. So the value of current is given as V by R, which is nothing but 20 by 3.23, that gives 6.19 amps. So this is the value of current that flows in this circuit. So here the current value is 6.19. So again when you move little bit back, you see this is the current that flows through this circuit, right? The total current is 6.19. So this current gets divided between these two resistors. So again here, since the resistors values are different, we have to use the current division rule. So when you use the current division rule, you see here total current into opposite resistance. Okay, the resistance, because we need the current that flows through this 3.2, because when you move gradually backward, this gives our 2 ohms, right? So we need to calculate the current that flows through this 2 ohm. Therefore here we are calculating the current that flows through this 3.2. So total current into opposite resistance divided by total resistance. So here when you just put on the values, you see here the current that flows through this 3.2 ohm is 2.380 amps, right? So again when you move gradually upwards, you see. So the current that flows through this path, it is nothing but 2.380, right? So again, when you reframe it, you see 2.380 flows through this, and again the same 2.380 flows like this. Okay, can you make a guess here? Am I making it correctly? So the current flowing through this 3.2 is 2.380. Where comes this 3.2? It is a combination of 2 and 1.2. Therefore, the current flowing through this is 2.380. Again, when you proceed backward, how comes this 1.2? It is a parallel combination of 2 ohm and 3 ohm. Right? Am I making sense here? I hope so. So now the next thing is we need to calculate the current that flows through this 2 ohm resistor. So here what is the formula again? Total current into opposite resistance divided by total resistance. So when you use this formula, you see here total current into opposite resistance divided by total resistance, right? So here we are arriving with the answer as 1.43 amps, right? So our final answer is 1.43 amps when you compare this with the step 1 answer. So here it is again 1.43 amps, right? Therefore, we can say the reciprocity theorem is verified, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.